Welcome to this video on Z-intervals. We're going to discuss how to make them and what conditions and steps you need to make to follow in order to completely answer a question about Z-intervals. So this one is just Z-intervals for means. So that's when we know the population standard deviation is when we use a Z-interval for means. When we don't know the population standard deviation, there's another interval we're going to use, which is in the next video. All right, so when you're going to do a Z-interval, you have to check three conditions. The first is that you had a randomized sample or a randomized experiment. And in real life, hopefully you've already thought about this before you do your experiment or observational study. In AP land, we kind of go backwards. We're given the study and we have to make a confidence interval. So in real life, you should take this into account when designing your experiment or observational study. Then we have to do the large count. It has some other names, like some people used to call it the normality check. Large count is good because that's really what it's trying to make sure you have a big enough sample size. Since we're doing means, we need our sample size to be greater than 30, so then we can use the central limit theorem, and our sampling distribution will be approximately normal. If that's not the case, we can do a normal probability plot, and we'll review that in class if the sample is small, because if it shows that the sample looks normally distributed, then we can assume that the population is probably normally distributed, and therefore our sampling distribution will be approximately normal as well. So that's another method if you have a smaller sample size. Then there's independence, which is only needed for observational studies. You don't need this for experiments, because what this is trying to make sure is that if you're sampling without a replacement, which is not experiments, that your probabilities aren't changed enough to mess with the results. So with sampling, we want to make sure that 10% of our sample size, 10 times our sample size is not more than the population, or 10% of the population is not less than the sample size. So we use this 10n less than n in order to check it, where n is our sample size and big N is our population sample size. Or some books will also write it as n is less than 0.1 times the population. So however you like, whichever, it means the same thing. All right, so let's talk about the formulas. They are on your formula sheet. This top one, standardized test statistic, this is what you use when you're doing your Z, where you have your x minus mu over sigma. So that's not for this section, it's just right above the confidence interval statistic. So here's confidence interval. You probably won't actually use this on your formula sheet because you'll know these off the top of your head. But for the Z interval, our statistic is the mean of the sample, then plus or minus what's called Z star or Z critical. Then it's time the standard deviation or standard error, depending on which interval we're using. Right now it's the standard deviation of our statistic because we're using the population standard deviation. Standard error is when you're doing standard deviation using your sample statistics. So you calculate the standard deviation based on your sample, and that's not this one. So standard error, standard deviation, this is our formula. So let's talk about the Z critical. That you get from doing inverse norm on your calculator. So what we're trying to do is our confidence intervals are centered around the mean, and we want to maybe get 95% of our data. We want to make sure we encapsulate 95% of the possible sample means that we could get from our sampling distribution. So if I do that on my calculator, you just go to second distribution, inverse norm, 0.95, and you have the mean is 0, standard deviation is 1, because we're looking for a z-score, so we don't want to mess with the mean and standard deviation. Enter, enter. And you'll notice it's symmetrical because it's centered, and we're going to use plus or minus 1.96. Now, if your calculator doesn't have that menu and it defaults to doing z-scores to the left of whatever number, whatever probability you give it, if it's the area to the left, then you can just give it half of the remaining percentages. So since 5% is left after the middle, you can divide the 5% between the two tails and just put in that number if you don't have the left, right, center option. All right, so here are the critical values for specific confidence levels. You could figure them all out doing the same method. The most common one is the 95 that we just did, which is 1.96. So if we want 95% confidence, we're going to multiply by 1.96, our standard deviation. If we want 90%, we multiply by 1.65, 99, 2.58. And as you can see, if I'm multiplying our standard deviation by this z critical value, if I multiply by 1.6, I'll get a certain width of our confidence interval. If I multiply by a bigger number, the plus and minus gets bigger, so I add a bigger number to x bar and subtract a bigger number. So we're going to get wider, and then here we'll get even wider, and here we'll get even wider. So as we go up in confidence, our confidence intervals get wider, because if we're getting a wider confidence interval, we're going to catch more data, and therefore we'll be more confident. But at a certain point, the confidence interval becomes too big to be meaningful. So 95% is the accepted one, because it's kind of it's big enough to be fairly confident, but not too big that it doesn't end up practically meaning anything. All right, so we're going to do one example here, and we're going to use video terminals, so like this lovely picture. We know that and we want to test the screen tension. That's what we want to measure. We know that when the process is operating properly, sigma is 43. We're taking a random sample of 35 screens, and the sample mean is 306.3 newtons, so that's our x bar, and that's our n. And we want to construct a 95% confidence interval. So I am going to teach you a little acronym to remember what to put in your confidence intervals. So we're going to do PCCI. The P stands for parameter. So you want to say, what are you measuring? So we're trying to extrapolate to all the tension strength of all video terminals, because it's the population. Then that's our P. Then for C, we want to check conditions. So we're going to check that we had a simple random sample, which was stated in the question. Actually, our sample size was 35. But 35 is greater than 43. And so that means this needs to be, for independence, we need to have more than 350 monitors in the population that were created that day if we're sampling 35 of them, so that the independence check works out since we're sampling. The large count, where we're trying to make sure our sample is large enough to be able to use the central limit theorem for means, is the n greater than 30. And then once you check it, it's good to write the sampling distribution then is approximately normal, because that's what that count is checking for. All right, then we have to do our calculations. To show your work, you can just type in the numbers here, and then we can do it in the calculator, and it will calculate the whole confidence interval for us. So you can write them out and then define the numbers, just have the calculator do it for you. And then the last step is the interpretation. We are 95% confident that the interval of 292.05 to 320.55 contains the true population mean of tension strengths of the video terminals. So let me end the PowerPoint here so I can show you on the calculator where to do this. So we are going to go back to our stat button, and now we get a new thing. We get to go over to tests. Now, we're not doing any tests yet, we're doing intervals. So if you look down at 7 and 8, you got Z interval and T interval. We're going to do the Z interval, not the Z test. Don't choose Z test, Z interval. All right. Then you can do data or stats. So data is if you have stuff in your lists that you've taken from a list of data points, or you got the data yourself. We don't have that, we have the stats. So our standard deviation is 43. Our mean was, that's a good question, 306.3. And our sample size is 35. Our confidence level is 95% there. And you press enter and it gives you your 2 endpoints. It does all the work for you, so then you know you didn't type in anything wrong when your order of operations trying to do it out yourself. So that's what I mean. You can write this out, but then just put it into your calculator in the Z interval and it'll do all the work for you. All right. Last but not least, we have margin of error, and this is when you want a certain margin of error, and it's usually used to figure out what sample size should I get, and the margin of error is always after the plus or minus of the confidence interval. So, because it's what you're adding and subtracting to the mean. So, what is the error in our confidence interval? And so as your sample size gets bigger, your margin of error gets smaller. And that's really usually the only thing you can play with, because a lot of times your confidence level has to be set at a certain value. And your standard deviation, it is what it is. So usually the sample size is the only thing that you can play around with. All right, so let's do this last example. If we had the mean teacher's salary in Massachusetts with 95% confidence, we want to do it with an accuracy of $2,000. So pretend the standard deviation is $10,000. So we know our Z critical. We want this less than or equal to our margin of error. So we have 1.96 times 10,000 all over the square root of n is what we're solving for. Has to be less than or equal to 2,000. So I will let you do the algebra out for that, but you should end up with 96.04 has to be less than, n has to be greater than or equal to that. So if it helps out, you can rewrite it. So that means we have to use 97 a sample size of 97 in order to get that margin of error. All right, I hope you learned something in this video, and the next video will be more confidence levels.